afternoon, CAMX. Welcome to the demo zone. My name is James Jones. I'm the lead technical support manager for Composites One. I'm joined by several of my Composites One colleagues, as well as several of our supplier partners. So as we get started with the demo, we're going to tell you about the materials and processes we're using. We're going to be doing a closed mold processing demo with 3 different closed mold processes, all in identical molds. So we're going to start out with the vacuum infusion process over here to my left. We're going to be infusing carbon fiber, epoxy, foam core hardtop. Over here in the center, we're going to be using a reusable silicone vacuum bag to infuse a fiberglass hardtop. And over on the right, we're going to be doing a Light RTM process with a fiberglass product. We're going to be using different resins in all of these, and we'll explain the process as we're going. So Jeremy and Jeff are going ahead and finishing the layup. So they're putting in the core material now. We're using a Aerospace C7055, and they're going to go ahead and finish the laminate. They're using some Aerofix 3 spray adhesive to tack everything down. And while they're working, I'll go ahead and describe some of the benefits of closed molding. One of the first benefits is it's a cleaner working environment. As you can see, we're working here. We don't have the Tyvek suits, the rubber gloves, or the respirators. We have reduced emissions because all the resin is enclosed in containers. It's going to be injected through MVP equipment. Some of the other benefits for the parts are we're going to have much higher fiber content, lower resin content. So that's going to give us higher strength and lower weight. We're going to have much more consistent parts. It's a very repeatable process, all 3 of these, and we can have reduced cycle times. So they have the core in now, and so what Jeremy and Jeff are doing is they're putting the inner skin in of the carbon fiber. We'll talk more about that in a minute. So with the vacuum infusion process, it's a fairly low volume. So we're going to be sealing the bag manually. We have to put pleats in it. You'll see that. But it gives you very high performance parts. It's very good for very large structures, one-off parts, fairly low volume, or where you need very high performance. Kind of in the center, a little bit higher volume, we have the reusable bag process. And so it replaces the sealant tape and the vacuum bag film with a reusable vacuum bag. So it makes our cycle time faster, so we can crank out more parts. And finally, we have the Light RTM, where we have a semi-rigid upper mold, and we have a fixed cavity thickness, so we can have a finished part on both sides, and have a very quick cycle times. So the closed mold process follows Darcy's law. So there's a few variables with that. We have permeability, pressure, resin viscosity. With carbon fiber, we have typically very low permeability. We're using a product from Vectorply that has a micro mesh actually in between the layers that helps with the resin flow and wet out. But we'll be adding a external flow media to help the resin flow on this part. For pressure, we're only using atmospheric pressure. So full vacuum on the vacuum infusion process, and we have half vacuum on Light RTM. We're using low viscosity resins. In this case, we're going to be using an epoxy resin, and then we'll be using vinyl ester and polyester in the others. And they're low viscosity, like I said, around 100 to 300 centipoise. And as you can see, all the reinforcements go in the mold dry, and then we'll seal everything under a vacuum bag and then inject the resin. So to tell you a little bit more about the laminate, we started out, it's already in the mold so you can't see it, but I want to introduce Chris Meixel from Chamarant to talk about the first layer we have on here, which is a woven carbon fiber from Chamarant. Chris, right behind me.
Good afternoon, everybody. I'm Chris Mikeso with Show 'em Around North America. The first ply that went down in here was a 245 GSM Vail stabilized twill that we manufacture. It lays into the part very nicely. The Vail stabilization keeps the toe in place for that Class A surface type of aspect. Allows for easy handling, and you could be a little bit rougher with the carbon fiber as you lay it in there, and it'll give you that Class A surface, not having certain carbon toes out of place or anything that might cause a reject in the part. So the Vail can also add some additional properties such as advanced toughening and aid in resin flow. You can lay that Vail in there either against the tool surface or behind it and create that very, very nice carbon surface that they're going to try to get for this lid. Thank you.
Thanks, Chris. And so backing up the Chamarral Seaweave stabilized material is a couple of products from Vectorply. We have the CBX 1200 plus minus 45, and then covering the core we have the CLTI 1805 090. Jordan, you want to tell us a little bit about those?
Yeah, the first layer of Vectorply product is CBX 1200. It's about 300 GSM product. It's standard plus or minus 45 product. It's very common in Vectorply. We've got a number of different weights from 3 ounce all the way up to 94 ounce in that product range. So they're using that here for the first layer to give a good surface finish behind the Chamarral product. And then backing that after the core is CLTI 1105. And the 05 has a mesh in it. It really is there designed for two things, really for better cuttability, but the most important thing is just the resin encapsulation around the fibers. We were talking about earlier how the permeability of carbon is a lot less than the glass, and so this just gives it an extra insurance knowing that the fibers are completely wet out. It can be a challenge under core like this sometimes to get, if resin flows too fast, and that just gives you the insurance knowing that it's fully wet out. But these are two very common products you can see over at our booth today, but we have those micro mesh on a lot of our other products as well. So come check us out.
Thanks, Jordan. So you can see the process materials are going down on the part now, and so I'm going to introduce Doug Perry-Hunter from Composites One. He's our process materials application manager to tell you more about the process materials.
Thank you, James. So as you can see, the guys have already started laying down some of the process materials. So the blue that you see here is our Infuply 2. So it's a combination flow media, mesh, and release film combination. So in this case, it was already pattern cut in our kit cutting facility so that way they didn't have to do any trimming. It just dropped down in. The nice thing about that material is that it has a hot perf P16, so it helps wet out through the Z-axis really well for infusion. The other materials that you'll see the guys are using is obviously the Aerofix 3, which is the spray tack in this case. And then they're installing the Vector Vac around the periphery right now, Vector Vac Red. And then they have their feed already installed, which is the Vector Feed Brown. And then, of course, they've got their resin infusion connector already down. They are using VacSeal 2042 sealant tape, which is the same tape that we'll use through almost all the demos here. And then, of course, they'll bag it with 205B, which is a beautiful soft film that comes in a variety of widths and applications for infusion. Thank you, James.
Thanks, Doug. So now I'll let Tom Augustiniak from Polytech tell you a little bit about the epoxy and infusion resin we're going to be shooting this part a little bit later in the demo. Tom?
Thank you, James. Thank you all for coming out today. So for this infusion, we're going to be using one of our epoxy systems that's a low viscosity, the CPD 4281A, 4284B. It gives a fast gel time for this size part, which is a perfect setting for it, as well as giving you a good heat deflection temperature, which is in a moderate range. Now, with that same system, you're able to just modify the hardeners that we have for it to give you different pot life as well as heat deflection temperature. We do have also a lot of other systems like our 2110 Series A today with different hardeners if you need to have a little bit more higher elongation and different properties for a higher heat deflection temperature. For this part here, like I said, we're using the 4281A, 4284B. It's a great general purpose infusion epoxy system, not only for making finished parts, but also for making tooling epoxies as well. So for this one here, it is a great epoxy for it. It will give great flow with a low viscosity of 150 centipoids, and it'll be a great infusion for it.
Great. Thanks, Tom. So now, while they're finishing bagging this vacuum infusion part, we're going to come over to this reusable silicone vacuum bag part. I'd like to introduce my colleague, Dan False. He's a fellow technical support manager with Composites One.
Thanks, James. Hello, everybody. Dan Falls from Composites One, TSM for the Ohio Valley region. Here to talk a little bit about reusable silicone bags. So Jeremy and Jeff, they're bagging up their mold with a bagging film, which is just a straight sheet that you'll see them pleat and put together. It's a one-time use only. A reusable silicone bag, which we have here, runs the same principle as the vacuum infusion, but the bag itself is made to the net shape of the part. So it is made to the part. It can be used over and over again, 500 times, 1,000 times some customers have, so you're not throwing these consumables away every time. You can do different types of infusions and resin introductions. What we're using today, we have a Rovacor material. It has a core built into it for flow media, so we don't need any additional flow media to enhance our resin flow, although we'll show a little bit later, or we could show it right now. This bag itself has a resin runner, a vanishing run, which you might have seen something along the lines with Charles earlier this morning. This is a little more basic and simple of a run, but I have a collapsing run. If I apply vacuum to this secondary channel, you'll see the run collapse. And so we'll introduce resin into here. It'll run along that runner. And then as we're pumping our resin towards the end, we'll disconnect that. Atmospheric pressure will go back into this chamber and relax the bag like you see there. And when we pull the bag off the part, we should see no evidence of that channel. Permanent channels can be built into bags that would leave a chamber or a channel of resin. Other flow media can be used under the bags to move resin. So there's various different ways of moving your resin along the bag. We're choosing this today just to demonstrate the flexibility of the bag, the different things you can do. Another little thing that we're doing, if anyone's familiar with silicone bagging, we did ours a little different this time. Typically, you'll see a V channel in your mold, and you'll see a high spot on the bag that engages into that V channel for vacuum and a breather. A lot of customers say, I want to get into silicone bagging, or I want to try it. I have a mold without a flange. What can I do? Well, there's all kinds of alternatives. We just created two separate vacuum chambers here, and actually we connected them together as one, so we're going to pull vacuum at one source. But by doing this, we can pull our vacuum and we can seal down to the mold and do our infusion. So a couple little things different, with the bag that we're doing here. So next, I'm going to pass this off to Travis. He's going to talk a little bit more about the material in here and what it's going to do, and we'll keep this rolling. Thanks.
All right. Thanks, Dan. I'm Travis Irvin with Shomura. We're using two products here today. The first, the top layer here that you can see, is our standard Rovacor 450 B5 450. It's a combination of chopped strand glass stitched together with a polypropylene flow media. It's a nice light stitch that allows you to shape and conform the product to whatever detail is in your mold. As you can see here, it wraps down around the radiuses and tucks into corners very nicely. The second product, it's a little more difficult to see, is on the surface, and it's a new product for us called Rovacor FM. It starts out as our standard Rovacor product, the same 450 B5 450, But to that, we stitch a 72 GSM polyester veil to help improve surface finish. You may be, if you're making gel coated parts now, you may be laying down a similar product against the gel coat before laying down your reinforcements to help as a print blocker to keep from the glass fiber printing through to your gel coats. With Rovacor FM, those two products are combined into one, allowing you to lay it down in one efficient motion for improved part quality and Class A cosmetics. So if you'd like more information, come see us at booth Y44, and we'd be happy to help. Thanks.
Thanks, Travis. And Dan's going to tell us a little bit more about the making the silicone bags.
So the construction of this bag is a spray up process primarily. We're using a swirl product for this bag. It's a 2-part platinum cure silicone, 10-to-1 ratio. You can put it on in a number of ways. You can extrude it through a mixer, you can brush it, you can trowel it, and you can spray it as well. Again, primarily the system is appropriate for spraying. As I said earlier, basically we're starting with a profile to build our bag off of, which gives us the net shape of our B surface, so to speak. When we made this bag, we physically had a part in this mold and we sprayed off of that part to make the bag. So we had our offsets in place to make the bag. The process, again, was a combination of extrude material, spraying material, but basically you're spraying layer upon layer and building a thickness. We like to shoot for a nominal 1/8-inch thickness with our swirl material. You go a little less than that and the bag will not hold up as well. You get too much heavier than that and you're really just wasting material. So we found an 1/8 inch, maybe a little north of an 1/8 is a ideal thickness for the material. One of the great things about swirl is you don't necessarily need any kind of fabric reinforcing. A lot of the bagging systems you have to reinforce with a fabric mesh. The swirl you do not. The swirl material also is very forgiving in the fact that you can spray and you can leave and go to lunch, come back in an hour and start spraying again, whereas a lot of the 10-to-1 materials you have a very tight window where you need to put the next application on. Swirl is no different except for the fact that the window is wide open. It's at least 24 hours where you can apply and the material bonds to itself and becomes homogeneous to itself and becomes one. So it's one of the real nice things. Another nice thing about silicone bags in general is they're very easy to repair, they're very easy to modify, and they're also very forgiving. An example of that is this part here, we actually sprayed our bag off of a part, and in our imaginary world of hard tops, we decided for some reason we needed a little bit of stiffness, a little bit of reinforcing in here. So we added some Airtex core material in here just because, and we're still able to use the same bag. So the bag has enough forgiveness and flexibility that it'll stretch around these 3 pieces of core that the bag wasn't intended to do in the first place. So again, it makes making modifications easy, making repairs easy. So it's a system that works great, especially when you're running small to medium-sized parts like this. It's an excellent system to use.
Thanks, Dan. So we can go ahead and seal the bag up and get this one ready for injection. And for the injection, we're going to be using a resin from AOC. It's a low-profile polyester resin, the R985 series. Low viscosity, so it's good for several different liquid molding processes, has good repeatability and good cosmetics. We're going to shift gears and talk about the Light RTM process. So as I mentioned before, Light RTM uses a lightweight, semi-rigid counter mold instead of a bag. Yeah, if we can show this, this lid over here. So some of the features, so we're using it's called Light RTM because the counter mold is fairly light. You know, we can lift it with 2 people. It's made out of fiberglass, and it's clamped with vacuum. So some of the features of this mold is we have 2 seals. So we have an inner seal and an outer wing seal. And we pull full vacuum between that, and it clamps down to the flange. So at full vacuum, we have 14 PSI, or over a ton of force pushing down for every square foot. So for this particular mold, we're gonna have about 40,000 pounds clamping it shut. And then we'll pull half vacuum in the cavity, inject the resin at 2 points at the front and back. And these are fittings from RTM North 4104s that were molded directly into this part. Resin will run around the resin runner on the outside, and it'll flow towards the middle to our vent in the center. So we're doing this a little bit, so this is typical for Light RTM to flow from the outside in, but the other 2 processes we're going to be flowing from the inside out. So you'll be able to see how the different flow works. A couple of other features for this mold is we have these 2 hard stops here. So that controls our part thickness. The mold's going to close until those 2 stops land on the flange, and the part's going to compress the reinforcement that's in the cavity. There's a few different ways. Do you want to go ahead and close this? Or? There's a couple of different ways to make these upper tools. You can do a calibrated sheet wax in the mold cavity. So we would make it on the A mold, the lower orange portion. We would put calibrated sheet wax in there to our part thickness, and then we would hand laminate the upper mold on top of that. This particular mold was actually made using the infusion process on a CNC cut pattern. So you can make a very accurate A mold and B mold for the Light RTM process. So we've already closed it up, but I want to tell you a little bit about the reinforcement and the resin we're going to be using. I'm going to introduce Jordan Hart from Vectorply again to tell us about the reinforcement, and then Ashley Duncan from Plint to tell us about the resin we're using.
All right, so the glass being used here is SC40/6VC. The SC40 is a product that's really designed for high conformability. We've got a number of product lines with Vectorply, but the SE series is really designed for extreme conformability and really designed for using with low profile resins like we're using here. We've got a couple other ones out there, the SM series for its all glass products for high temp or corrosion properties. And we've got our M products more on the cosmetic side, and we do a combination products as well, where we combine a lot of our knits with a lot of the CHOP and the polypropylene. So we use different substrates. This one's using a polypropylene substrate, but again, the whole purpose of this one is designed for conformability. It's the same product being used on this mold as well. You can see it fits really nice around a lot of these sharp radiuses, so it works very, very well when it comes to conformability.
Thanks, Jordan. Now to talk about the resin, we have Ashley Duncan from Plint.
Thanks, James. I'm Ashley Duncan. I'm with Plint, and for the Light RTM part that we're demonstrating here, we're using our Plint A6125 resin system. This is a low-profile resin that's designed for closed mold processes like Vacuum Infusion and Light RTM, low viscosity system for that. You can see some of the features and benefits on the screen above, but there's a couple that I do want to point out that make this product a little bit more unique compared to some of the other low-profile systems that you may be familiar with. The first one is that I want to note that this resin system has a low peak exotherm in the laminate. Typically, we see less than 150 degrees Fahrenheit in the peak exotherm on that. And then the second one that I want to point out is that a lot of our customers have reported that they've experienced less B-side scumming on your counter mold using this product. So I wanted to just real quickly go through, this is a low-profile system that's designed for enhanced cosmetics with no barrier coat and rapid cycle times. You can see we have a hardtop that's displayed over here that you can see that's been gel-coated, and you can see the surface finish. But real quickly, I wanted to explain a surface finish test that we did to demonstrate this. And you can see up above, we did a small part cosmetic evaluation. The lamination schedule is a typical lamination schedule that you may see in a marine small part. The resin was initiated with 1.5% MEKP9 peroxide, cured at room temperature, demolded after an hour after infusing. We post-cured this for 4 hours at 150, but you do not need to post-cure this resin. It's an ambient cure system. We just did it to accelerate our test. After we did that, we took a BIC wave scan to register the surface profile, and you can see that there's virtually no change in the surface profile on that. There's one more that I wanted to show you in terms of the cosmetic comparison that you can see. So the panel on the left is a panel that was infused with the 6125, our Polent A6125 resin, no barrier coat, no skin coat. The panel on the right is a typical infusion resin with no barrier coat and no skin coat. And you can see, you can't see it now, the surface profile differences in those. So I do also want to just point out before I pass the microphone back over to James that when you scan the QR code that you see above, you have the opportunity to download our Polent closed mold product line guide.
Thank you, Ashley. So it looks like we have all three of our parts sealed up and ready to go. Are we ready to go on the infusion? Ready to go? Silicone bag? Ready to go? Light RTM, we're ready to go. Yeah, we're gonna start recircling. While we're doing that, I'll let Tom from MVP tell you a little bit about the MVP machines we're using for Light RTM and silicone bag.
So both machines that you see here are identical. We are able to use different resins and different catalysts, no problem. And they will perform exactly the same. We have pre-calculated the amount of resin that we would like to go into each of these parts. And so there is a stroke counter that your operators, as you learn your part, you will know how much resin by strokes that you would like to go into a part, and therefore helps with the lack of waste. Love to eliminate waste, and that's one way to do it. We have some safety features. We have some performance features in these control boxes. It's a completely pneumatic box. We need clean, dry air. We do not need any electricity, fortunately, with this control box. We will inject material, specific amount for each mold that we've learned over the course of developing these presentations, just as you would develop those numbers as you're producing parts. And we'll inject. We'll get them injected. We'll flush the systems, obviously not into the part, but loose of the part, and clean up, easy injection, and we'll be in good shape.
Thank you, Tom. So I guess I'll count us down. Are you guys ready? So 3, 2, 1, let's go. We're using a few different flow strategies. We have a center feed on the vacuum infusion process. We have a center feed on the silicone vacuum bag. And we have a perimeter feed on the Light RTM process. So the Light RTM is a little bit hard to see. This is a translucent resin and gel coat. A lot of times you can make it fairly translucent and you can see the resin flow through the process. You can see on the silicone vacuum bag that our collapsible resin runner is creating a nice straight flow front. So we're flowing from the center out. The reason we're filling from the center is we only have to flow half the distance. You can see we have a similar strategy for the carbon fiber epoxy infusion. As I mentioned, we're using different resins, different reinforcements with different permeabilities. Carbon fiber is a very small diameter fiber, so you want to infuse it a little bit slower and let those fiber bundles saturate with resin so you can get all the properties out of the laminate. The glass fibers are a much larger diameter, so you can fill them a little bit faster. These reinforcement products have core materials, flow core materials constructed into the fabrics, and so we're flowing through the fabric. We don't need the external flow media. So you can see for the Light RTM, we're using a vac pack from RTM North. This is a Venturi vacuum system, so it runs off of compressed air, and it's got electric valves in it, so it shuts off when we reach the vacuum that we need. So on the left over here, we have the flange vacuum that's at full vacuum, and on the right we have the part vacuum that's at half vacuum. So how are we doing on our parts? Can we see where this one is?
About halfway right here.
Yeah, it's a little bit difficult to see the resin through the top. You'll see it witness out of this 1/4 inch vacuum line here. And then we have a small resin catch pot, also from RTM North, with a little paper bucket in there to catch any resin that'll come out. So Dan just disconnected his vanishing resin runner, so that the bag is going to collapse and you won't see any marks on the part from the resin runner once the part is full. We just have the corners left to fill. How's it doing there? You can see we have 2 feed lines coming from the machine. They're teed together. So it's feeding our resin runner at the front and the back, racing around, and it's flowing to the center. The Light RTM fill tends to be a little bit faster because our resin content's a little higher, so we have a little bit higher permeability in the mold cavity. But our resin flow front is shrinking as the part is filling. So the perimeter feed is a little bit faster flow than the center feeds. So we've stopped this one temporarily just to let it fill a little bit. One of the things with the silicone bag is you can actually pump it in faster than the laminate will take the resin, and it'll lift the bag up and balloon the bag. You have to be very careful doing that because you could outrace the laminate and not have a wet surface on the mold side. So Dan has slowed the machine down to, we probably have enough resin in there already to finish the part. So I think he's done. He's about ready to stop and put a couple more strokes. So over here on the Light RTM, you can see the resin coming out of our vacuum vent. We have a few bubbles. So we'll wait till that runs clear and then clamp that off. And then our part is full. Our full vacuum on our clamping flange will keep the mold closed until the part cures. So Steve's clamped the vacuum vent on it now, and the part is full. Now we just wait for the resin to gel and cure. And it looks like our silicone bag part is finished. So we clamp the feed line. We're going to maintain vacuum on the part. I think Dan had probably mentioned we have breather strips. In this case, we're using peel ply. It's just any fabric that will flow air, but it has low permeability, so it slows the resin down because we don't want to suck the resin back out of our part. So you can see once the resin hit the peel ply, it really slows down. And then our our resin will gel and cure. So on the vacuum infusion process, we're still flowing through the InfuPly, and with the InfuPly, we flow across the top and then down through the thickness. And like I said, with carbon fiber, we want to make sure we fill it a little bit slower to get complete wet out of the carbon fiber. And our resin viscosity with epoxy typically starts out a little bit higher than with the polyester or vinyl ester systems.